So yeah, I hope you have some power left. It's even in the afternoon, but today we were going to supercharge some Lambda functions to be more effectively in your daily usage. Who am I? I'm Raphael. I'm an IT consultant working in cloud projects in Germany. But besides my daily work, I'm also part of the AWS community. I'm a community builder. We also heard that Simon was presenting it. What it is a community program from AWS itself to share knowledge and help other people solve their problems. And besides that, I'm also running my AWS user group in my hometown in Karlsruhe, Germany, southern Germany. So I'm quite active there as well. And if you want to connect with me, of course, I'm active on all the social media. But also short-term, my company I'm working for is Codecentric. It's a consultancy company in Germany. We have a couple of locations. So if you have ever customers in Germany and need some help, feel free to reach out to us. And yeah, but today we don't want to talk about me. Today we want to talk about serverless Sven. Serverless Sven is working at an e-commerce incorporated company, and they're building an online platform to sell items on the web. And of course, as it's done nowadays, they're running in the cloud. Quick look at their architecture. They are a serverless first architecture team. So they use a lot of common services like API gateway, Lambda function that serve the API requests, store data into the DynamoDB, then have some asynchronous processing part after that. So they forward some items from the DynamoDB using a pipe to an SQS queue and then process them further with Lambda function, for example, to send out some notifications to the customer. So one day a customer comes in and asks Sven, where is my order? And Sven says, okay, no worries. I'll look into the logs and see what happened. So Sven pulls up his logs, and actually what he sees is this bunch of string messages, all of course, they have a timestamp, but besides that, that's all they see. There are errors in the messages, there are success messages, and so definitely cannot reason anything from that. So he kind of gets back to the customer and says, sorry, I don't know what happened because our logging structure is too bad. As a good team, the team comes back together and do a post-mortem to identify what actually went wrong. And they conclude they have missing information in their logs. And how to solve that? One of the best practices in the cloud world is use structured logging to really have a better way to troubleshoot issues in your log files. And then Paula comes up. She already used Powertools in a side project and suggests there is a library called Powertools for AWS Lambda that has a logger functionality. So let's try that out. So what is Powertools for AWS Lambda? It is a library maintained and created by AWS. It uses different open source tools under the hood, but the main orchestration part and development part is done by AWS employees itself. It's an open source library, so if you have issues or want to contribute, they're happy to get your contributions there as well. Let's see how we can use the logger capability for Powertools on AWS Lambda. So first of all, today all my code examples will be written in TypeScript. We come to other languages in the end. So what you have to do is install the library, go to npm, install the logger framework from Powertools, and let's say we have a basic Lambda function that's handling an API request. Sorry, it's a little bit hard to read probably in backend, so I'll try to explain it. So it is a Lambda function getting in an API gateway request, checking if there is a response, if there's a request body, if not, validating the returning a nobody response, then it's passing the request body, and finally store the order in the database and have some basic error handling and logging some messages for success cases and for error cases. So how can we use the logger library? or framework part of the Powertools, simply by instantiating a logger class. It's a class-based library, so you're instantiating a new logger, give the name for the service that is generating log statements, and then it is a drop-in replacement for all your console's log statements. You can simply use the logger class and log the message you had before, but now additionally it could take extra arguments like context information, for example the customer ID, so you can now have a correlation between the log message and the customer ID. It's the same for error cases. You can pass in the error and say this error happened for this customer, for example. How does it look like? So now we are emitting not a string value to our log files, we're emitting JSON objects to our log files. So we have a structured way of troubleshooting our messages. You see it, you can easily identify which log level happened, what is the message, which service emitted the message, and even have additional information like a tracing ID automatically ingested if you're using X-Ray. And of course, our custom attributes is all part of this one log message. What does that give you? It makes log parsing way easier. You don't have to extract informations by regex parsing or something like that from your string messages. And finally, definitely better filtering options because you now can address exactly these attributes from the messages in your queries for troubleshooting. So let's have a look at a log message, for example, the error one. Now you have an error object in this log statement and have direct access to the error log, the name of the error that was emitted, what the location was the error was exported, and what the stack traces can directly access and troubleshoot. And if you compare to the previous logging statement where it was all encoded within one string message, it's way easier to identify these issues, and you can see the customer ID is also part of this statement. And of course, you can now plot your log statements only with those attributes that are relevant for troubleshooting, because you can narrow down the message to the relevant attributes. And now you can use, for example, CloudWatch Insights to write more effective queries to troubleshoot your issues. So in this case, for example, we only show the level, the message, and the customer ID of the messages, and then we do a group by customer ID, so we can see which customer is most affected by our current problem. And CloudWatch Insights gives you, for example, some simple visualization features directly, but just by using simple structured logging and using other AWS tools as well for troubleshooting. The logger capability also includes persistent log attributes. So if you want to add attributes for each following log strings, like the customer ID, you don't have to specify it for each log statement. You can specify it once, and then it will be added to all the following log statements, called persistent log attributes. But you can also inject additional Lambda function information that is coming from the context, and therefore they use a middleware framework called MIDI. Luckily, we have one of the main contributors here in the room, Luciano. So if you have further questions to the middleware framework, go over to him. So what you can now use is this middle framework, MIDI, the Powertools library. Provides some middlewares itself, so it will automatically inject, for example, the memory size that was used, the function name that is emitting the message, and stuff, or the function ARN, and if the invocation has been called, so it is automatically added to the logs, to each log statement. And finally, you can also add a custom log formatter. So if you have some specific requirements or integrate with some other logging tools like Datadog, and they specify specific formats, you can provide your own log formatter for log emitting. That's Logger for Powertools AWS Lambda. Moving on. Next day, consumer of your API comes along and says, hey, your API is slow. So Sven says, no worries, we have tracing enabled. Let's look at the traces and see where the latency comes from. So Sven goes into X-Ray, and actually all that he sees is, yeah, we have tracing enabled. We see that there was a request invoking our Lambda function, but that's basically it. Also, if you go into the detailed segments of this trace, all we have is, yeah, the API is slow. We have no further information in our traces here. So Sven has to go back to the API consumer again and say, sorry, we don't know what happened, why our API is slow. We need to investigate further. So the team comes together again and identifies, okay, we have tracing enabled, but currently our tracing solution does not get any value. So what we can do is extend our instrumentation for our library, for our Lambda function to get more detailed information in the traces. And for that, Paula again suggested, hey, Powertools has a library or framework or utility for that called Powertools Tracer. So how do we use it? Again, install the library. Each of these capabilities I will be presenting today are all part of separate packages, so we install them separately. And let's have a look. For example, in this case, we have a DynamoDB client that is using storing the data in a database. Then we have a function getOrders that is doing a query to the DynamoDB. And finally, iterate over each order from the DynamoDB result and enrich it with some customer information by calling the get user information, and finally return the result of the merged calls. So how can we now extend our traces with more information? Simply by instantiating the tracer class from the Powertools library. With that alone, you already get detailed traces about each outgoing HTTP call. But in this case, we are doing a DynamoDB call. So we want to have a detailed view on the traces for DynamoDB. So we can simply use this tracer class and wrap it around our DynamoDB client. And now we have detailed view on the DynamoDB calls. What do I mean if I say detailed view? So as I already mentioned, by simply instantiating our tracer, we now see our HTTP calls and our DynamoDB calls. And if you go down to the segments that are part of this trace, you now have detailed views for each API call to the external API, how long they took, and which for DynamoDB the same. It was a query operation to some table Powertools orders, all by just simply using this tracer, instantiating the tracer class and wrapping it around this SDK. So, but we want to troubleshoot our issue. So what we find in these traces now, we see, okay, there were a couple of calls to this external API that always calls the same user. It's the get user one. And so also the latency is coming all from this part where we're interacting with the external API. So we can deeper look into our in this function that is doing the external API call. In this case, it's the get user info. So what we're going to do is we wrap a segment, or open a segment to have a detailed view on only this part of our application. So we open up a segment, make our operation, and then we close the segment again. So we have a separate item in our trace. So now we see, okay, it's definitely the function, the get user info function, but it takes 227 milliseconds, but only 25 milliseconds are part of the actual API call. So it must be something else that is happening in this function. So we can go now deeper into our function code and see what is actually happening. And now we easily see, okay, someone added a sleep operation to wait 200 milliseconds because there was some rate limiting issues, and probably because we were always fetching the same user ID, we run into rate limiting. So what we can now do with all this information we gathered from properly instrumenting our code, we can refactor our code and simply move out the get user information because we know we're always calling the same user. We can move that out of our loop operation, remove the sleep operation, and now have way better response times in our API. So in this case, for example, we reduced it from 1.8 seconds to 700 milliseconds because we used all the insight we gathered from the trace information and refactored our code accordingly. Other capabilities for traces, you can also add annotations to the traces. So let's say this trace is in correlation to a customer ID. We can put in an annotation, and annotations are quite nice because annotations are visible for one thing in the X-ray console, but more importantly, annotations can be used to narrow down our traces. So if we know that all our defects are happening for one customer, we can include this attribute now in our query and narrow down the trace results only for this customer. If you have more broader information you want to put into an X-ray trace, you can use the helper function, put metadata, and put in any object or value that is relevant for troubleshooting your traces or your issues. So, for example, maybe some API results that can be helpful, or some parameters you put in to send to an external party. You can put it in the metadata, and then whenever you open a trace, you can see the metadata related to this trace. Exactly. In this case, I was adding the orders object into our to our trace, and in the X-ray view, now see the full object that is added to this trace, and that can be helpful. That's Tracer for Powertools AWS Lambda. So now a business requirement comes in, hey, what are your KPIs for the last 12 months? And Sven says, no worries, I checked the logs, we have structured logging, we can easily extract that information from that. Unfortunately not, because we want to save money, so we only have a log retention for 1 month. So all we could do is actually extract KPIs or data points from this 1 month period. So Sven again has to get back to his business partner and says, sorry, I cannot get you the numbers, we need to improve on that. So the teams comes again together and narrow down the issue, and probably metrics depending on log retention is not a good extracting metrics from logs is not a good idea. There is a better version. Of course, we should publish custom metrics. Metrics is a part of a CloudWatch where you can store data points way longer than cheaper than log statements. And Powertools has also a library helper function for that, to easily publish log metrics to CloudWatch without calling their API. So what it actually does, you instantiate, as always in Powertools, you install the library, you instantiate a metrics class, and in this case we're saying for the same service we're generating metrics under this namespace. And if you go into look at our code, now every time instead of generating a log statement, or next to generating a log statement with the customer ID that we use to generate our KPIs, we now explicitly emit a metric. So we say whenever there is a successful order, we add a metric to our invocation by and counting by 1, increasing the count by 1, and the same will happening for the failed orders. And now what actually happens is, by the library, it of course, it needs to be flushed at the end of the invocation. There's a middleware for that as well. But the more important part is, what it actually does is it is emitting a JSON object in your log statement in a so-called embedded metrics format. That is a specialized format from AWS provided, where you can emit log statements, and then the CloudWatch agent that is reading your log statements is then generating the actual API, the actual data points in the CloudWatch metrics, and you don't have to pay for the API calls to put metrics there. And yeah, so now we have metrics, and we can easily narrow down and calculate based on the metrics data our KPIs for our business units, depending on what we are meant to do. Maybe you want to have multiple dimensions of your data points. You can also add a default dimension. So each data point has a dimension, and for example, for environment or region or whatever is relevant, you don't have to encode that for each data point you're producing. And there are some other helper attributes, like it can also be automatically capture cold start, so it's generating data points for each cold start that is happening. And finally, we could also merge the log statement where we can add it to the we can replace the log statement that we use to generate some custom data points by just adding metadata to our metrics emitting. So each embedded metric format also has these additional attributes like customer ID, and so we can build still metrics from CloudWatch Insights queries, but they are not part of the data point. But if you have high cardinality data, they are still correlating to the data points that are actually generated. That's metrics for Powertools AWS Lambda. So next thing is the external API now needs to have an API key. So what Sven says, okay, we will add that to make an authentication to this external API key. So what the team identified, we need to add this authentication API key to our HTTP request, and for that we need to read an API key from Secrets Manager. Powertools, again, has a small library to help you with that. It's called Powertools Parameters that helps you read parameters. In this case, the parameters features includes getting parameters, cache them for a certain of time. So when there are multiple invocations, it automatically reuses previously fetched values. It supports deserialization and giving you type hints, for example, for TypeScript, that you have some certain interfaces directly associated when you get these values from Secrets Manager. And the supported providers are Secrets Manager, System Manager, AppConfig, and DynamoDB. So if you want to load variables or parameters from any of these providers, you can easily use this utility function. It's simple as, for example, defining an interface. Our API credentials in the Secrets Manager has an API key and an app ID, and then we call this getSecret function with our interface and the secret name, and then we can specify how long this value should be cached. In this case, 300 seconds, and it should be automatically transformed from the JSON string that is returned from secret to a JSON object, and then it will have the same structure as in the interface. But it's only a type hint, it's not enforced, this structure, unfortunately. Genau, yes, and now you can use it more type safe in TypeScript because you provided the interface. That's parameters for Powertools. Moving on. Now we have another issue. The customer complains he actually didn't get our emails. So Sven says, okay, no worries. It's probably something in the async part, probably something with the queues. So let's have a look at the queues. So recap as our function. Every time an order is stored, we publish, we use DynamoDB streams to publish a message on a queue that is then processed by a Lambda function which sends out the emails. What the team identifies is, okay, there was one item in the batch that was failing all the time, and this was basically stopped our processing of the queue because it's always run into errors, and the full batch of messages was always failing. The solution for that is, as Simon also mentioned this morning, there is a nice feature from AWS called Report Partial Batch Failures, which you can tell him which messages failed, and only the failed one will be put back on the queue, and the successful will be deleted. And Powertools has actually a helper function there as well to manage this orchestration from processing a message, making keep track of if it succeeded or not, and if it's failing, report back to the AWS service. So how does that look like? So for a little recap for those people who don't know what partial batch failure is, basically when you consume a SQS queue in Lambda, you get probably a batch of messages delivered to your function. And then if one message is failing in this batch, the whole batch will be put back on the queue. If you don't use this partial batch failure functionality. If you use partial batch failure, you can report back, okay, from these 3 messages, only that one, the final one, failed, so it will be put back on the queue, and the other one that exceeded will be deleted from the queue and not processed again. So how does that look like? We have a simple Lambda handler, just getting in the SQS queue and iterating over each message, and then calling the notify customer function. It's supported by SQS, DynamoDB string, and Kinesis data stream. So if you consume messages from that with Lambda function, you are able to use this batch processor. Batch processor basically takes care of iterating over each record of your batch, invoking a handler function that takes care of handling the record or this one message in the list, and if it succeeds, it will say okay. If it fails, it throws an error. It will automatically generate the correct payload that is returned back to the Lambda service that is working. So what we do is we install our package and then instantiate a so-called batch processor and saying, okay, you are processing SQS message, you are processing Kinesis stream or whatever supported stream is available. And then you're basically wrapping our Lambda function into this batch processor and saying, okay, here's your configuration, here's your incoming event, and here is this one function that handles one record. So in this case, it's the underscore handler function that is just, its purpose is just to process one message. And the batch processor then itself takes care of orchestrating the task and invoking this underscore handler with the payload from this one record. And if it fails, it will store the message ID and process the next message until all the messages are processed, and then put back the failed one on the queue. And this is how it looks like. So it report the response of the Lambda function then actually is an array of messages from the batch that failed, and only that one will be retried then. That's batch processor. So finally, customers received multiple emails. So the team gets back and say, okay, we look at it, what happened, why customers got multiple emails. Unfortunately, SQS consumption is at least once delivery, so if you have a high load, it's highly possible that the same message from SQ will be delivered to the handler multiple times. So the solution for that is add idempotency to your email notification, so it sends out email only once. And Powertools, again, has a nice helper function for that, idempotency. With idempotency, what you actually get is you need to have a persistent storage. In this case, it's DynamoDB. With DynamoDB, it keeps track of which messages have been processed, what was their result. So if there is a second invocation, so the first time you're invoking a Lambda function, it generates an idempotency key, stores it in a persistence layer, and then invokes the Lambda function, records the result of the Lambda function, and when there's a second invocation happening, it gets the same idempotency, has a hit on the database, and returns back the result from the database without actually invoking the Lambda function. So how can we use that in our code? So again, our example with our SQS Lambda handler that is processing the messages. All you have to do is specify a configuration. So please use this DynamoDB table and use this part of the incoming message as an attribute to identify the message, the uniqueness of the message. In this case, we're using SQS and the MD5 hash of the body. And now we can, again, wrap our SQS handler with the idempotency, so the handler that is processing one message by wrapping it with the make idempotent function from the Powertools library, providing the configuration, and the library itself makes sure that the message is not processed twice. So what it actually looks like is, in the end, you have the same handler, just wrap it with the configuration in the make idempotent from the library, and you're good to go to have idempotency added to your part of your application. And in DynamoDB, you see then when a message is in progress, it has a status in progress, and after the invocation is done, it has status completed, and the result of the invocation is actually stored in a DynamoDB as well. So We're not mostly done. Idempotency is one of, we have one left. That is, now the team has, okay, a security assessment had happened and they identified, hey, you don't actually validate your incoming requests. So that's not good. You need to validate your payload before processing. So Sven says, okay, that's not good. We will fix that. And how do we fix that? For now, we are only passing the body, but not validating it. So we need to add some validation to our request handler. And luckily, Parser from Powertools team is a solution for that, to have validation easily added to each Lambda invocation. It uses not only the library parser from the Powertools team, it also adds a third-party dependency called sort for validation. So now we're having our Lambda function from the beginning that is currently not validating our request. So what we need to do is specify a schema, how the request should look like. Then we can use and now we can use the helper function from Powertools to actually invoke a middleware that is taking care of validation. So you specify it's an API gateway request, so it automatically extracts the body from the API request and validates against your specified schema, and then gives you the result into the Lambda function if it was successful or not, the validation, and so you can react on that result from the validation. That's the final piece for now. Powertools AWS Lambda supported the team with several capabilities like logger, metrics, idempotency, badge, and parameters, and tracing capabilities. But if you're not using TypeScript, there are other languages there as well. So check out. Unfortunately, they don't have feature parity yet. So the teams are working on that to have the same features in each language. But most of the core features I presented today are available in each language. And with that, if you want to try out Powertools, there is a workshop from the team itself. I can highly recommend it to get some feeling how it works, and or try it out on your own. This is the landing page, as I said, available in multiple language. And if you want to get in contact or have further questions, I'll be in the hallway or on social media. And I hope I didn't spend too much time. Thank you very much.